Napapilido ni Adrian. Sandali ah. Magellan yun. Banuelos. Adrian. Okay. Okay, so you're all 39. 38 pa rin sa akin. Meron akong na-miss. Palagay ko may na-miss ako. Kasi ang nakalagay doon sa ano ko, sa 39, kalagay lang dito 38. So kulang ako ng dalawa. Dalawa yung missing. Ito isa. Gian Rivera. Wala pa din si Gian, ano? Si Pamplona. Okay, let me know, ha? Okay. Ano to? Damag. Okay, so alisin ko na lang itong ano, please. Please, okay. So, ito na. Ito na. Okay, allow me si... lumabas na si Rivera. Okay. Juan Rivera. Tabuelas pa lang yan. Nakalagay na si Rivera, Cantuba, Dimano, Pay. Ang wala is Christine Pamplona. Ito wala si alright. Banuelos. Banuelos. City, you're here. So, alright. Okay, almost everybody. Dito na lang sa irregular pentagon. Ito na ang kulang ko. Yeah, regular pentagon. 1, 2, 3, 4. Apat. Minus 4. Alright. I-off ko muna kaya yung yes? Syra? Hello? Syra?
Kung po yung ano, nagdamala ko.
Teka, sadali. Bakit garbled? Sadali, ayun ko.
Para po ako yung
Garbled yung ano eh. Garbled yung hindi ko maintindihan yung boses eh. Ay, definition. Sadali ah. Okay. Okay. Sadali ah. Okay. Pwede ko yung aking audio. Naloko na. Sandali ah. Just a moment. Audio. Audio. Dapat yung audio ko eh naka-off. Sandali ah. Okay. Hello, can you hear me? Hello? Hello, maliwanag ba yung audio ko? Hello? Syra? Hello, Syra? Hello? Parang may problema yung microphone mo. Hello? So, okay na. Okay na. Anyway, I'll just, hindi, nandito, halos lahat nandito na. 40. Okay.
So, mag-start lang ako ng start recording. I-record ko lang itong ating ating activity. Okay. And also take the snap. Uh, okay. Cancel muna. Ayusin natin. Okay. Uh, snap. Okay. File. Save as bias crossover. Wait. Recordings. Latest is save it at 1.5. Okay. So, sinave ko yung picture natin. Okay. Now, yes. Yes, Desiree? Hello, Desiree?
Sir, si Rivera daw po ay absent dahil sinamahan ng kanyang mother po sa oncologist.
Oh my God. Si Rivera, Gian Rivera. Okay lang.
Opo.
Sige. Anyway, nakita ko naman siya dito. Okay lang. Okay, nako, sana nagagamot naman yung cancer, sana magamot. Okay? Ah, kung minsan nakaka-stress din yan eh. Alright, so here is so far the findings ko na yung iba kasi na i-record ko na eh. Meron akong pinost na team reference material, so you can refer to this. I think this was done good sa team bite, so I posted it as a student contribution. Kasi unang-una sila unang nakapag-submit eh. Okay, so 18, most of you are doing well. I think you know on the previous one. Now, what I intend to do is every time we have a new topic, I think I will ask you to do some algorithm so that you will be honed in a thinking process and circuit analysis. Okay, so I am preparing to send you this. Let me show you. Oh wait. Let me. Uh, okay, I've been checking this. Okay, so uh, I'm doing the. I'm now in the Zener. Let's say this is distribution bias current bias crossover. This is the bias crossover that I will ask you to take a look. I forgot to include here the LT spice. All right, just a moment, okay? Uh, Module differential amplifier. So uh, copy. I should be including this LT spice paste. Crossover paste. Okay, this is the LT spice. Now, uh, again, I will show you the LM741, this one. Okay, so you see this one. Maybe I will still wait for your submission. I think you made good submission. I like the way you answered the question and your tabulation. Uh, that become very interesting. Okay, now here is the whole circuit. So we have studied Q10, Q11, and Q13. This is what you got in uh, TAS 03. Now, task 04, I will like you to do the following. Okay. Uh, take a look on the Q11. So, whatever the current in Q10 will be the same in Q11. Okay. So, let's do that so that we do a little analysis so that we will do something here. This uh, current, okay, Q10, all right, that is one. And then Q11, so they're almost the same. 702, 702, more or less they are the same. Okay. This current came out to be collector current. The collector current is 700. So this collector current is, well, it doesn't pass through C1 because that is AC. It will supply Q14 and R8. So Q14 and R8, and also it will supply the base of Q18. All right. Now, take note. The Kirchhoff's voltage current flow is the collector current of Q11 is equal to the current through R8, current to the collector of Q14, and current through the base of Q18 and current to the collector of Q20. So we can neglect the Q20 is just a circuit, a protection circuit. If there is an excessive current in R9, it will turn on and shut off Q18. So that is we can take that for granted. What is important here is the collector voltage between the collector to emitter voltage of Q14. Okay, so that is there's a collector to emitter voltage that supply the bias, the voltage bias of the base of Q18 and the base of Q19. So this one is biased by Q14. You can make it short circuit, and that will not be a problem. By the way, if you notice B3, I have the sign 0. So actually, what you can see here are small. But if I put it on the original, which is one volt, and I run it, okay. All right, there is a small changes here in this current. Okay, so let me run it again. Okay, so let's see what this is. What is this current voltage? So that is the voltage, 1 volt. Okay, so it will supply this, but that is a small voltage, and it will supply. Okay, you can see the voltage at the output here, out here, 12 volts to 12 volts. That is maximum output. But you would see that there is a current in, we'll see the current in Q11. Uh, don't think that the current is changing. This is 675. The maximum is 675.42 and the maximum is 675.96. So this is just a ripple current. All right. But what is interesting is if you take a look on the current here, this portion, okay, okay, that is almost not changing current. 678 to 668, okay, there's a change in current, and also uh, the base current here also changing. This one is changing. Okay, you can see that there is a cutoff here, cutoff current. So, and also here, there is also here. Okay, so this is cutoff current, cutoff current. All right. Uh, 10 microampere. This is 35 microampere. This is larger. All right. Now, let's take a look. What is interesting is this. The voltage across this. There. Okay. So there's a voltage of 1.39, 1.39. So almost constant voltage. Okay. And then let's take a look on this. Okay. Okay. So you do not see any distortion on that portion. Okay, there's no distortion here. Now, because there is a bias from here up to here. Now, what happened if I do the following? Suppose I short it and then short the base emitter. Uh, okay, that will be fine. Okay, and run. There is still an output voltage. Okay, no problem. But if you take a look on this small portion, there's some. Oh no! Actually, I cannot see anymore this portion. Okay, okay. So you would see that there is some sort of there. Do you see that? Can you see this? There. Uh, that is the what we call crossover distortion. It's about point something volt. So that is something that you want to eliminate. So if you cut this off, you if you cut this off and run it, okay, and then oh no, oh no, window tile vertically, oh no, and then take a look on this there. So there is no crossover distortion. Okay, uh, do you get it? Hello. Do you have any question about this? This is important. I don't know what will be your career in the future. Maybe uh, you may be engaged in audio amplifier, which you will be handling a drive circuit, less distortion, and high power audio amplifier. So, in case you engage to that, this is something that you will be studying. Okay. Even that, if you're doing with circuit design in IC, you will still encounter this like in 741. So 741 is my representative circuit for you to be familiar with. All right. So now there is there is a technique here. I will ask you to do something. Uh, this is the maybe I should okay, I should open that uh, assignment that I will ask you, task 04. Sorry if I give you much assignment. I want you to do exercise in designing. Uh, I think that will be useful. Hopefully, it will also be a review. Uh, and then I will be opening this, what we call bias crossover, and take a look on this Zener. So there's a Zener. Okay. So this is the one that I will ask you to do. Okay. I will ask you to do the this one. Okay. So same thing. You put your So I put the LT spice. It will be also supplied. And okay, so maybe I should show you the LT spice. So this is the portion. Okay. And you should know the technique. Uh, it is hard to analyze a circuit like this together with this. So, what could be the equivalent circuit? Actually, it is some sort of Thevenin's equivalent circuit, but a little sophistication. I put a little sophistication in that, okay? So, allow me to show you the uh, technique. So, remember, before I give you the equation. This time, I will not give you the equation. I will ask you to make the equation for yourself. Now, if you try to remember what you did in task O3, the same technique, but this time I want you to do it yourself. So this is some sort of, I would say, Thevenin's equivalent circuit, or you may call it. As long as you're using current generator, that's no problem. So I take the current generator of IEQ11, and this is about 675. That is very simple how you do that. And then I have a power supply of 15 volts here, supplying it here, and this is also supplying the 15 volts. So the current flow here will also return to the ground through this power supply. And since this is the current generator, the voltage between this and this will just be adjusting itself. The voltage across the current generator, uh, it has no voltage actually. So if you apply 15 volts, 30 volts, it's fine. So the voltage across the current generator will be 15 volts plus the voltage across transistor Q14 and the negative voltage that is negative 15. Okay, so that is the voltage across the signal generator. What is important here is the current that is supplied by Q11. Now, you will be asking, sir, how did you get the Q11? How did you get this one? Well, simple. Uh, we make this one, uh, we make this one zero. So, simple zero. And run it. So, you can see that This one, the output will have no output because it's zero. So then we will look at the supply current here. Here. So look at the supply current. So that is so about well, this is a very small time. So 67.92, 67.04, and maybe get it somewhere here. So you can estimate it about 675.98 or something about 6. Okay, so that is only an estimate. You don't have to be very precise. What is important is what is important is you have a current supply approximately. Okay, so you have the current supply here. All right. Now I will be asking you to do the following. Of course, one, this is the task. Well, it looks okay. Haba pala ito. Okay, so uh, you divide the task among yourself. Okay. Then you create the equation for computing. So I don't know how many equations you have. One, two, three. But you know the transistor equation. You know the equation for BBE. You know the equation for IE, IB, IC, current. So this is Kirchhoff's voltage law, Kirchhoff's current law. Then you need to compute for BECEQ14. And that BECEQ14 is the voltage drop across R7 plus the voltage drop across R8, and then you get the BECEQ14. Well, remember, transistor is a current generator, so the voltage between collector and emitter depends on R7 and R8. So, all right. So you do this. Then you create the algorithm. How do you solve the equation in number one? So that is your call. So I did not provide anything. Compare your result with spice simulation, and they are spice. Now there is something here I need you to understand when we call sensitivity. You have so many parameters in a circuit. Sensitivity is simply the parameter, a certain parameter you want to know if a certain parameter is sensitive to another parameter. So this one we are interested in BECEQ14. So if the current here is varying, then you want to know will the voltage how much is the voltage varies. So that is sensitivity. So what is the sensitivity of Q14 collector to emitter voltage to the supply current of IEQ11? So you can do that by delta. Reduce, let's say 10 microampere, the supply current, and then check the output voltage, and then uh, reduce, increase it by another 10 microampere, and then compute the delta. You can do it using the simulation. So that's one. The other one is, since you did your computational, you did your algorithm, you know the equation, and then use your equation to compute the sensitivity. All right. So, the question that I need you to explain is: should the BCE be sensitive or not? If it is sensitive, any small change in supply current, it will the voltage will change. If it is not sensitive, it will not change. So you need to explain why. So maybe I can give you already the explanation. It functions as a Zener diode. So it is expected that the voltage will be always constant because it is providing bias to the base of Q18 and the base of Q19 so that you can remove the crossover distortion. So you are removing the crossover distortion. So that is the reason why you need to keep it constant voltage. All right? All right. So that is the one of the, but of course you try to explain it in your own way. All right? All right. Pwede ba natin gawin ito ngayon, Syra? Hello, Syra. I will uh, I will post it as a assignment, and then we can start doing this. And tomorrow I will add something again. For this one, I will ask you to do this, and of course, for tomorrow, I will ask you to. We will do the analysis. So this is the bias for this, and then we will analyze the current flowing through this and through this, the bias. Okay. Then after this, we will also discuss the bias for the preamp. This is preamplifier. This Q10 and Q11 is your main supply. Q11 supply the back end. This is the back end. And then Q13 supplies the front end. All right. All right. So, the thing that I want you to do is I want you to do computation with LN741. Uh, I used to kid. You are also meeting other student in other school. Well, I want you to be very proud that you know the computation of all the transistor in LN741. Of course, if you know the computation in LN741, you can also know the computation for LM308 and other circuit because this is everything. Okay? So something that I want you to be proud that in this design, you were able to compute the circuit of LM741. So I still have 4 more weeks to complete this one. So let's do this first. The Zener diode. Most of the time, we are doing is Zener diode. We are using current generator, voltage generator. Now this is the actually this is a voltage generator. So you will be computing this one. Uh, Use your algorithm. I did not provide any equation. I want you use Kirchhoff's voltage law, whatever. I want you to create your own equation. Of course, your equation will work uh, if you compare it with the result in this LT spice. All right. So I think I should not. I'm starting. I'm starting removing the spoon. So this time you do your equation. Then we will go to the next one. Okay, Shaira. Is it okay? We can spend the next hour. Okay. So guys, wait, not yet. So okay. Uh, I will restart my recording. Okay. Uh, New link. Okay. Just a moment. This is stop recording. Of course, I need to open this one. Okay, now I will start the recording. Mm. At least I have uh, the image of this. All right. So uh, I will check uh, teamwork, task team. Okay. So I will ask you to anyway submit. You almost complete the submission. So this one. Okay. But before that, this is the crossover. All right. So this is the healthy spice. Okay. So crossover. This is the, of course, uh, this did not include the LT Spice, I think. If I open this one, oh no, I will not open it. So I'll just delete it. Okay. The delete everything except this one. Okay. Delete. Okay. This one and this one. Okay. So this is the Ziner. So you will have here the bias current, the previous one. You can make use of it. Okay. You will use the Zener and you can also refer to LM741. Okay. So uh, let me click this one. Well, I'll get the LM741 in the original state. So, okay. I'll make it 1 volt. There's a 1 volt. So it is up to you to change this one. Okay, so I run this one. Okay, okay. All right. I save this one. All right. So I close it. Let me check it again if it is properly saved. Okay, it's one. Okay. This is the LT Spy. So I will have all of this. Zip. Okay. So by the way, the instruction is clear. I think I have bias crossover. So this is the bias crossover. So this one, I'll put it in this side and put it also in this side. Okay, I will now create assignment. So I will ask you to do this today and tomorrow. Okay. So bias crossover. So I'll put it here, the bias crossover. Of course, if you can, okay. The title here is, I will call it task. So I have an extra task of 4. Okay. Due date. When do you want the due date? Next week. Okay. So Wednesday. Okay, Tuesday next week. I think you can finish it today. Okay. Shaira? Shaira, try to do it. Ano. Okay, so uh, uh, download uh, and do the exercise, the uh, uh, exercise. Okay, so this one I will assign, and the that will be November 12th. Okay, so assign. All right. So please download, check. You will create your own algorithm. I did not provide the file for the algorithm. So this time you create your own equation, you create your own algorithm, and I'll check. So uh, uh, you would see that most of your uh, analysis still follows the basic engineering analysis. Kirchhoff's law, transistor exponential circuit, uh, what do you, hybrid parameter of transistor. So you're using that. Uh, plus numerical. So you create your own numerical technique. There are many numerical technique, but of course, I just ask you to use your own. And then you are now analyzing the circuit, the 741. I hope I can finish the 741 with 2 or 3 meetings. And then we talk about oscillator. And then if there is still time, we talk about power supply. Because power supply make use of an oscillator. So we will be discussing about control system. Okay? So go ahead. We go asynchronous. I will still keep the Google Class open for any. But you can now log off. Okay? Uh, you can log off to continue working on the assigned task. Okay? Of course, all right. Leaders, is it okay? Well, maybe I should be. I think Syra should be talking with the leaders. Okay. Uh, I will still keep this open and I will check some of the paper. Uh, of course, I will check the paper so that you can see. Okay, if you have any question, you can just batch me in. But I will do the checking of the words in this Google Classroom, and this will be open. And okay, so okay, we go now. Oh, got it, sir. Okay, so log off to continue working on the assigned task. Okay, I will check your submission. Mission sa uh, open in Google Class. Okay, so that's it. So while you're doing your work, I'm checking your paper. All right, I'll be checking your Google connection. Reload. Uh, Google Class. Okay, continue. All right. So okay, so go ahead. Let me know if you were able to. What happened? Why I can't open this one? All right, all right. Review Word. All right. So Google Classroom task. Okay, I was able to finish this one. So okay. All right. So this one check. So ooh, okay. So I will have the. All right. There's a turn in. This is the turn in. Okay. So what was the turn in? Okay, it's good. Almost everybody are submitted. I will finish this uh, quintessential. This is Hazel, Lawrence, and San Mukte. All right. So uh, I'll check Hazel, Hazel Mendoza. So you have here Bangidista, Prenado, Hazel Mendoza, Sacmonte. Oh, Hazel has not submitted yet. Hazel, okay. And Mercado has not submitted. Anyway, I'll check Hazel. I think this one is good. Okay, so November 5, 1:02 p.m. November 5, 1:02 p.m. That is Hazel. So I'll just simply Control C, Control B. Uh, what was the time? 1:02 p.m. Okay. 1:02 p.m. All right. So let's see. Download. I'm here. All right. No comment yet. So I'll download Hazel's work. But I will still remove this one so that I don't get confused. This is Hazel word. Okay. Okay. This is Hazel word. All right. So uh, download.